Hello everyone, my name is Michael Young and welcome back to Exapunks. So we need to redeem ourselves. I feel like after our poor performance on the past challenge, that our ranking in the top 250,000 of people good at my job is in jeopardy. So we need to do better. We need to not fool around so much. Let's go ahead, create your own games for the Tech Redshift, optional. You're really gonna make a game with this? Why? I'm not offering a reward for it. Not everything I do is for you. One of those intangible things. A sense of accomplishment, self-actualization, a need to redeem oneself. I'm not good at abstract concepts. I'll have to observe you closely. Do I actually need to create a game? Because I kind of don't want to. Let me look at the manual. Like we have to, okay. So yeah, you could actually create like data files that would like make sprites that would move across the screen and stuff. Ooh, there's an audio system. I'm gonna play with it. 2 square waves and 1 triangle wave and 1 noise channel. What does that mean? Square and triangle. Link 801. You know, this would be tricky because there's nowhere to store like game state. You just have to like, I don't know, you'd have to like move offsets around and that kind of thing. Here, copy, there's a number. Copy 60 into square 1. Square 1, sure. Lovely. Copy 61 into square 1. And it's like 1 per frame, so it's okay. We're not actually gonna make a game. I'm not that interested in redeeming myself, but I'm gonna make some music. Let me just see if I can get this to work. So we just want a bunch of these. Oops. Let's see, I've got a drawing of a keyboard in front of me in the manual, and you can actually specify which note to press by choosing a different number. So let me try like a random little thing. 59, 62, 59, 64, 59, 66, 68, 69, 69. Then back to 59, 62, 58, 58, 59, 65, 66, and I'm off by 1. 59, 66. No, 59, 65, 66. So if I were to actually like put this in a loop, like I'd probably make this a file, and then I could put it in a loop. Like, oh, there's like a G register. That's like, oh, I see. So like this would be the sprites. What's the C? I don't know. The location the sprite appears. I see. Anyway, let's just see what this does. Oh, I have the wrong number. Nope. Let me try it again. And I'm missing some. Okay, so let's add in a 58 right there. I'm trying to do the Westworld theme. $69, after 69 it would be what? $68 again, I think. Let's try that. I like it. Anyway, let's back out of here and we'll just go on to the next story thing. Continue the discussion of morality with Ember 2. We're not talking about morality. What are you talking about?
Okay, I have a real question to ask you. Say there's a trolley on a track heading toward 5 people. 3 of those 5 people are vegetarians.
Let them die.
There's a switch you can throw that will shut down a meatpacking facility that is located down the road. Unfortunately, the switch will also prevent the train from stopping because, wait, I may have reversed something. Recalibrating. There are too many variables here. Okay, let's return to this later. I need more data first, and I need more processing.
Trying to be all fancy. But life still sucks. You know what? A couple hundred years ago, well, maybe even a bit longer, 300 or 400 years ago, the average couple had 6 kids and 4 of them died before reaching adulthood. Today, for every 20 couples, 1 of them might lose a kid before they reach adulthood. That is progress. That's everything else doesn't matter. 4 dead kids per couple. That's the progress. Anyway, so digital library. Copy requested books on various topics from a digital library. Time for some research. Human physiology, human morality, normative ethics. Wait, am I really that predictable? I'll have to change things up soon. Let's get those books. Okay. Books are stored in the host corresponding to the first digit of their call number, while book's file ID is 200 plus the last 2 digits of the call number. For example, book 512 would be stored in the host 500 as 212. That seems needlessly complicated. Duplicate each of the books requested by Ember 2 and bring them back to your host. The call numbers for the books Ember 2 wants are available in file 300. They'll never request more than 1 book from the same host. Okay, and it's a straight path from 100s, 200s, 300s. They're all -1, 800. Okay. So we're trying to make a bunch of copies. So probably we're gonna want a new file. What's this do? It's not doing anything. Okay, we gotta redeem ourselves here. So let's come up with a good plan. So first of all, we're gonna have to say, if we have the number 512, if we're holding the number 512, then how are we gonna test to see if we're in the right place? Because we can't compare the number 5 to the character 5. That doesn't work. I don't think. Probably not. What if we use Swizzle? No, it doesn't work. No. Okay, so we're in 512. So maybe that means we need to go forward 5 times. So 1, 2, 3, 4, 5, 6 times. So if we need to go to 1, then we need to go 1, 2 times. Okay, so that's how we go from... Okay, that's how to get to the right spot. Is it always 5? Like, I wouldn't think so. Yeah, it's different numbers. So what I'm wondering is, do we want to have one guy carry the 300 around and then create files, create replicants that will copy the right one in each of these? Or do we want to divvy it up right here and have a bunch of them going out? I'm thinking we'll go along. So we'll grab the 300. Here, you're the curator. And then link. Well, but that will be more complicated because then we won't know. It would be easier, I think, to just go ahead and, well... And unfortunately, these aren't all in the right order. But it's no more than 1 per. Okay, so I'm gonna have, you will know, your X register will always be the first number of the room you're currently in. So, start you in the 1. So link to 800, and then link to 800 again. So now you're in the 1s. Well, no, we can go ahead and just start you at 0. No, we should start you at 1. Well, no, we can start you with incrementing. So here's your main loop. You're going to increment X. And now you need to look through your list for things that begin with a 1. Is there gonna be a way to do that easily? While storing the 1? I'm trying to avoid getting in the communication trap I did before. So we're gonna go out there. Like, we could create an EXA for every single value here and then have each of them test to see whether they belong here. So there's not enough room. I think that's a bad idea. You know, that might be the easiest way to do this, just to create a bunch of them. And then have each of them test to see if they're in the right spot. And then die real fast. Let's start by doing that. That'll be our plan for now. So its main loop is going to be add 1 and then link forward. So now it's here and its x is 1. Right? Let's test that. There. X is 1, and it's there. It's pointing at the first item. Now it's gonna walk its list. And for each 1, you see, the thing is, I want to copy its value. I think we're gonna have to do some communication. We'll have to replicate and then send the value. So repla copy book. Well, wait a minute. Once we get here, we're not gonna know how far along we are. So I think maybe it'd be better to go ahead and start in the gateway, like I was doing. Or start in our zone and dish them out here, and then have them all walk forward to the right place, and then walk back, so they know how far to go. Right? Let's do it that way. So you are not going to go anywhere. You're the curator. You're going to sit here, and you're going to set, here's your main loop. You're going to grab F into X, and then you're going to make a copy of yourself to go to book, and we'll mark that, maker that, go to book. And test and a file, and if true, if false, then jump back to main loop, otherwise halt. But how am I gonna store how far back I need to go? This is, I don't want to use the M to copy the books back one by one. I want each of these to go and get their book. But they have to know how far back to return. So I think they always need to store that X value. Well, they could each make a copy. So, okay, that actually kind of, wait a minute. So you're trying to make some new books. Does a new one have to store? Yeah, it does. A new one stores the name of the old one. So once 171 and 171 is there, so I should go ahead and have them start a file with the 171 in it. That will be convenient. Yeah, you can just carry along your own little register. So, okay, once you're there, go ahead, make a file, copy X into it, and then we'll have a travel to shelf, which will test if X is greater than 100, and if it's not, then we're there. So F jump, make copy, and we'll prototype that down here. If we is greater than 100, then drop it by 100, or drop it by 100, and store it in X again, and then traverse forward. Here, for now, just go ahead and sit there. I just want to see if, well, traverse forward and then jump back to travel to shelf. I want to see if everyone can get to the right spot. Let's test this. So grab the 300. It's stored 512. Now it's making a copy. Now the copy is making a file, storing 512 in it. Then seeing it's greater than 100, so it's dropping it to 412, and then it should traverse. Except we're in the wrong spot. We need to go forward one. Okay, let's have this guy grab 300 and link 800. We'll make all the copies in the gateway. There. So now we got this guy. He's at 512. He sees that he's above 100, so he drops it to 412 and goes forward. Drops it to 312 and goes forward. 212. Did he die? Where'd my 112 go? Where'd the guy go that had the 512 on him? Wait a minute. Try that again. So you're at 212. Where are you? You are standing here. And then you just disappear. No, there you are. The original one disappeared. Oh. Okay. Yeah, we can deal with that later. So 212. Then you go forward again. And you're still on the wrong shelf. Now you're going to go forward and you're on the right shelf. There. So they should all be in the right shelves now. They're just dropping their regular files there. Okay. So the first guy, once you've done all that, made all those replicas, you need to wipe your file first and then halt. Looks good. Looks good so far. I'm liking this. This feels, feels optimal. Feels much better than the entire time last time I was like, this is kind of flaky. This is not the way I should be doing it. This feels right. Okay. So we're at the shelf now. We're right there, and we need to add 200 to our X to get to the name of the book, and then we can grab X. Wait a minute. We can't grab X. We're already holding our copy of it. So we'll need to create a buddy. Is there always room for at least 2? It looks like there's always room for at least 2. Always room for 3 even, so someone can traverse past us. Okay, that works. Will that continue to be the case in all the different test runs? It looks like it's always the same layout. Okay, so we're gonna have to have 2. We're gonna have to have a reader and a recorder. So you're the recorder. So mark read book, and these should all be in local mode. So you are going to what? We're gonna have to start reading into X, I think, because we're gonna need to copy. We're gonna have to test to see if we're at the end. Which means we really need like a reserved keyword that can't appear. I'm gonna assume that the book will never hold a specific word, and we'll just assume. We'll hope. There's probably a better way to do that, but I don't know what it is, so we'll leave it alone. So Addy, Addy 200. So now we're pointing at the right book. Now we need to replicate at read book, and then have a new loop. So mark copy loop. In our copy loop, we're going to copy something from M to X, then test if X or do we need to do that? Can we just keep on seeing if there's something ready? I'm gonna try going the ready route instead. So you're going to test M ready, and if false, then finalize, and we'll prototype that down here. But if it's true, then you're going to go ahead and copy it into F. And then do the loop. Now in our read loop, And this is almost certainly going to need to wait an op for this one to pick up its book. So grab X, then it'll have a loop itself, mark read loop, and it will copy F to M and test end of file, and if it is the end of file, then we're done. So if we're not end of file, so false jump, read loop, otherwise halt. And on finalizing right now, I'm just gonna have it sit. Well, it'll wait. Let's go ahead and get here. In the first one. Or, well, which one got there first? So this one got here, it's EXA2, which is sitting here, it's trying to make a copy of 206. So the first thing it does is it makes a copy, which is now way down here, and it's gonna grab the book where you are going to do nothing, and now you are gonna, okay, you need to do nothing twice, I think, because it takes a turn for you to copy it in, because now you think you need to finalize. Maybe those happen simultaneously? Never mind. It's good. So you copied 206 into your file. That was not what I wanted. So, okay, we're gonna have to seek one. Wait a minute. If the books that we're picking up have a copy of their number in them, then we don't need to make the copy back home. We don't need to store that copy. We could just go ahead and start traveling. Here, get rid of that. Yeah, we could just straight out begin going. Let's make sure that still works. So, yeah, people are still getting to the right place. They don't have the book yet, but that's fine. They can make the book right there. Okay, so now that we're here, before we get to our copy loop, let's see. So we risk replicated. Now we make a copy ourselves. And let's see how that works. Okay, so you're making a copy. It's the 400, and now you're gonna wait a second and copy 206 into it, which is the name of the book that we're making right now. Out of instructions. Why did you run out of instructions? You're trying to send stuff. In fact, you have the word so right there. I think maybe I need a no-op while it waits because of this testing to see if it's ready. So a test to see if it's ready, and it is. It says it's ready, but it doesn't feel like it should say it's ready. I'm wondering if I'm not understanding this. Either way, so it grabs it, and now What's XA02 doing? XA20 doing? You are about to jump. Okay, so we need to insert a no op. After this. So no op. I think. Let's see. Okay. Now it's gonna be ready this time, so again it's not gonna finalize. Right? Where is it? XA2? Yeah. So it grabs the next character. So you want to... Okay, that's working. And it's gonna get to the end, probably. If it's not, we'll test. Now when we're done, when we copied everything, we want to seek minus 99999 and then copy it into our F, copy it into our X. That will tell me how many spaces back I need to go, using the same sort of travel to shelf, but backwards. So, mark travel home. And this will test to see if X is greater. It's the same thing. This X is greater than 100. And if it is, then we need to if it's not greater than 100, then we have to end. So end. If it is greater than 100, then we subtract 100 from it and link -1 and jump to travel home. Let's see if that works. Nope. They're ending up one too far back, or one not far enough. At end, keep going, one more space. Link -1, then halt. Yep. Okay, we're always taking a bit more code, but I think that's just our mark signs. I'm feeling confident. I feel like we did that well. We didn't take an hour and a half to get a suboptimal solution. We got a decent solution, and we always kind of had the right approach. We had to do a quick little dog leg to deal with the whole carrying the file to it, because we thought we needed to know the original number, even though the original number was already there. But we fixed that, and it turned out very nicely. Processing. Yes, this is what I wanted. Glad it's helping. I love ingesting a good corpus. Not that that's all I'm doing. I read the same way any normal human reads, by analyzing patterns of word recurrence and deriving correlations between concepts implicit in statistically significant word clusters. That's how I read. Okay, I'm gonna take a break here. We'll continue next time, so thank you everyone for watching. Until next time.